Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about equilibrium problem number 5, which is going to be the hardest of our equilibrium problems that we've discussed up to this point. So let's get right into the problem. And if you'd like to, pause the video right now and go ahead and copy, the prompt, and then start working on the problem. And when you come back after unpausing the video, we'll be working on this problem. So when we read the prompt, it tells us that we have a molarity of H2 as 1 molar and I2 as 2 molar. And we have no concentration of HI, but it does give us the equilibrium constant. It tells us that the equilibrium constant is equal to 50.5. So this is a little bit different than the other problems that we've had. The other problems we had initial concentrations, and then we had one equilibrium position, and we were able to calculate everything in the ice chart numerically and then use those numbers to figure out the Kc value. Well, this is a little bit different. This time it's giving you the Kc value, and it wants to ask you, the questions the prompt's asking you, what are the concentrations when it's at equilibrium, or what are the equilibrium positions, So what do we know about equilibrium? Well, we know that this thing has an equilibrium expression that's equal to Kc, which is equal to the products over the reactants. That's one thing that we know. And we know that this value is going to end up being 50.5. Well, if we have no HI, if there's zero HI, well, then the equilibrium constant can't be 50. So what we do know is that this reaction initially is going to shift to the right, and it's going to start producing some HI. Of course, the H2 and I2 are going to go down until it gets this value of 50.5. Well, we don't know exactly how much it's going to shift because we don't have any other numerical values up here. So what we're going to do is we're going to use some x's, So what we're going to do is we'll say, hey, H2, you're going to go down by a value of x. And this is a 1-to-1 ratio. So this also is going to go down a value of x. However, we got a coefficient 2 over here. So this is going to go up 2x. Hopefully all that makes sense. Now, when equilibrium is established, then this equilibrium concentration is going to be 1 minus that shift, or 1 minus x. This is going to be 2 minus x. And then, of course, this is going to be 2x. And what we're going to do is we're going to plug that information into the equilibrium expression. So the numerator is going to be 2x. And remember, it's squared, the whole term, One of the things that students do is they only square the x, but this exponent of 2 counts for both of them. So eventually that's going to become equal to 4x squared, The denominator is going to be 1 minus x and 2 minus x. And all of this is going to be equal to 50.5. And our job is to solve for x so that we can figure out the equilibrium positions. Well, to do this, it requires a decent amount of math. So the first thing we have to do is we have to be able to FOIL this, right? So when we FOIL this, remember, it's the first and the last, and then the inner and the outer added together, And that portion is going to end up being 2 minus 3x plus x squared. That's what this term is equal to when we FOIL it out, And then what I'm going to do is I'm going to do some cross multiplication. So 50.5 times this. So let's go ahead and do that. 50.5 times 2 minus 3x plus x squared, is equal to 2x squared times 1, which is simply 4x squared. I'm going to distribute the 50.5 throughout this term, so it becomes 101 minus 151.5x plus 50.5x squared is equal to 4x squared. I'm going to bring the 4x squared over here, so this ends up being 46.5x squared. And then just kind of put everything else into a situation that looks like it can be used for the quadratic equation, So we are going to use the quadratic equation. This is going to be your A value. This is going to be your B value, and this is going to be your C value, okay? And when we plug that into the quadratic equation, remember, it's going to be negative B, and a negative of a negative 151.5 is going to be a positive 151.5 plus or minus the square root of B squared, which is negative 151.5 squared, minus 4AC. The A is 46.5 times the C, which is 101, all over 2A. Okay, so 2 times 46.5. Okay, and then so X is equal to those values. Okay, and when we do the math there, X is going to be equal to 2.323 or 0.935. Now, one of these roots makes sense. The other one does not. Okay, the one that does not make sense is the 2.3, because if I plug in 2.3 for this x, 1 minus 2.3 would be a negative number, and you can't have negative concentrations. So this root, okay, would be wrong, okay, and the one that we have to use is 0.935. And if I plug in 0.935 right here, this value comes out to be equal to 0.065 molarity of H2. Okay, if I do 2 minus that number, it's going to become 1.065 molarity of the I2. Okay, and if I do 2 times the 0.935 number, I get a value of 1.87. So these are the equilibrium concentrations for H2, I2, and HI respectively. And the way that I can double check my work is I can take each of these numbers and plug them into this expression, and it's going to equal 50.5. If it doesn't, that means you've done something wrong. Okay, so please, when you're done with these problems, okay, when you're done with the problem, please plug it back into the equilibrium expression and double check to make sure that you have your K value equal to what the prompt is stating. Now, this type of problem is the hardest type of problem because it requires so much math. There are many times where my students understand equilibrium perfectly, but they have trouble with the mathematics of rearranging the equation and also plugging it into the quadratic equation. So these types of problems, they require practice and a lot of time and a lot of effort, but with a lot of time and effort, chemistry becomes easy. So I hopefully you found this content helpful. If you did, give it a like and subscribe. And when you leave a comment, it really does push out this information to other students that are interested in learning chemistry.